You can find gears in just about every man-made thing that has spinning parts. Analog watches, cars, coffee grinders, my bike. Turns out you can find them in nature, too. In this week's Science magazine, researchers announced the unexpected discovery of a rotating gear system in the legs of an insect. As NPR's Adam Cole reports, these naturally made gears help the bugs jump at lightning-fast speeds.
The planthopper is a little gray-green insect, a cousin of the grasshopper, with veined wings that look a bit like leaves. The juveniles, called nymphs, are slightly larger than a flea, but their tiny legs can still pack a punch.
If you've ever been kicked by a grasshopper?
I have never been kicked by a grasshopper. Well, I don't know if I would feel it if I had.
Oh, you will feel it.
That's Greg Sutton, who has been kicked by a grasshopper. He's a scientist at the University of Bristol in the UK, and he knows firsthand that grasshoppers and their insect relatives have powerful back legs, good for kicks and great for quick jumps. Planthopper nymphs are some of the best jumpers around. They can launch themselves hundreds of times their own height into the air in just a couple milliseconds.
It's such a short time, it's difficult to think about.
Now, jumping is trickier than you might think. You have to make sure both legs push off at exactly the same time. For example, when LeBron James goes up for a jump shot.
James is here, and we'll have this, something like that. Let's just run through it. Yeah, okay. No, I think it's sold out, actually. Let me just start like that. Whoa! Are you guys rolling on this? Yeah. That's a 90-footer. That is amazing. Oh, my.
In that moment, if one leg pushes off before the other, he'll go careening sideways. But of course, that doesn't happen.
Puts it in!
Jumping is easy for James. After all, his jumps last a full 500 milliseconds. His neurons have plenty of time to send their messages to both legs, so they'll kick simultaneously. And if they are a few milliseconds off, it's no big deal. But planthoppers jump so fast, they only have a couple milliseconds to synchronize their legs. If they're off by even a little, the jump will go haywire. But Sutton says they get it right almost every time.
Usually the legs extend within 50 microseconds of one another.
That's a tiny fraction of a millisecond. And here's the thing, that's faster than their neurons can fire.
So we were asking ourselves, how in the world do they get such precise synchrony between the left and the right legs?
So Sutton and his colleagues watched hundreds of slow-mo jump videos and examined the planthopper's legs under a microscope.
And we noticed these bumps.
A row of bumps along the curved inside edge of each planthopper hip. They looked like the ridges on two tiny cogwheels.
Before the insect jumped, it would engage these ridges.
And the bumps would mesh together perfectly. When one leg moved, the other leg would move with it. You can watch a close-up video of this on our website, and it really is a working gear system, the first ever seen in nature. This is a big deal for biologists, but the design of the planthopper gears has engineers excited too. Sutton says most human gears follow the same pattern.
If you see a set of gears, say pull out your watch, or if you look up gear on the internet, you'll see a shape of tooth over and over and over and over and over again.
But planthopper gear teeth are quite different. They're more hooked and rounded.
So what we have is a prototype for incredibly small, high-speed, high-precision gears, and that prototype is given to us by nature.
Maybe one day we'll replicate the planthopper gears using new techniques like 3D printing and put them to work in human machines. Adam Cole, NPR News.